Hello, testing. Hi, S. Saswin. Hi, Krishna. How you guys doing? Hello. Bam, I'm here. Alright. Good morning, or afternoon, or evening, wherever you are. We are trying more Microsoft interview questions today. Heck yes. Hi, S. Saswin. Hello, how you doing? Which screen are we on? Oh, this screen. So, I've been scrolling down the Microsoft questions list, and I was like, dang, it's actually getting hard to find questions that we haven't done yet, especially from the top. But then I was looking through the questions from the top, like, even though I've done some of these actually, I haven't done some of these in a while, and some of them I'm not confident that I can even do anymore, especially like LRU cache. So I'm probably gonna just go from top to down, and then if I don't have confidence on one question, then I'll try to do it. Like twosome, merge strings, merge sorted array should be fine. LRU cache sounds more difficult, so I'll give it a try. Yeah, LRU cache, Leetcode 146, here we go. Leetcode 146. I remember this did give me some trouble in the past too, so. And of course I forgot to sign in again. It's okay, I'll do it later. Design a data structure that follows the constraints of a least recently used cache. Implement the LRU cache class, LRU cache, in capacity, initialize the LRU cache with positive size capacity. Okay, and get in key, return the value of the key if the key exists, otherwise return -1. Void put, update the value of the key if key exists, otherwise add the key value pair to the cache. Update the value of key if the key exists, otherwise add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. The functions get and put must each run in O1 average time complexity. Okay, I think I have a vague memory of how to do this. LRU cache. Here's the example. LRU cache gets instantiated with size of 2. They try putting 1 and 1 key value pair. Put 2 and 2. They try getting 1. And they get 1 back, yeah. They put 3, 3. Okay, who gets evicted? It's 2, 2, right? Yeah, so if they get 2, they return -1. Okay. I see it. So the last key value pairs they put in are 3 and 4. So if they try to get 1, it's not going to work. It's going to return -1 and then 3, 4. Okay, I think I understand where this is going. Okay, I guess for simplicity, we can go with like a hash map first, right? Hash map. Yeah, key value pairs are like hash maps, right? Get key, just call the hash map. Return the value, I guess. Put, update the value of the key if the key exists, otherwise add the key value pair to the cache. Okay, we need to keep in mind that we need to update too. Evict the least recently used key. Okay. I have a vague memory of how to do this. I feel like we have to do a hash map with value. Wait, key is the actual key that the user sets, and then the value is a node, right? That contains the value, and the nodes point to each other, which represents their relative recently used order. So what do we do for get? return the value of key if the key exists. Okay, so we just go into the hash map, right? Get the node that the key is part of, the key points to, and then return the value in the node. What do we do for put though? So if the key already exists, that means we not only need to update the value in the node, we also need to remove it and then put it at the front. Let's do front. Sure. Front would be most recently used. And then back would be least recently used. Okay, that makes sense. Otherwise, add the key value paired to the cache. At the front, yeah. And if the number of keys exceed this capacity, we read from the back, I guess, and then evict that node. Yeah, okay. Sure, okay, I'm starting to see it now. In capacity, the constructor, this dot capacity in capacity, this dot capacity is equal to capacity. Okay, for linked list node stuff, I think it's, well, I think I'm getting ahead of myself. We should do a hash map, right? Hash map, and then we need a integer as a key, and then a node, custom node class that we define. Sure, we'll call this the map. We also need to define the node class node. What is it here? The value? Yeah, int value. What else do we need here? I'm trying to think what else we need. I feel like that's it, right? Int value. I think it's good to have size. Assessment size? You mean the capacity? Alright. Can we name this as size? Maybe it's more readable. Oh, you're talking about for node? I'm not sure if size would be a good idea for that. Oh, obviously they would need the next one too, right? And the previous one? Node next. Node previous. Okay. Sure, let's run with this for now. For linked list node stuff, often using bogus nodes for the front and back nodes is a good idea, right? To reduce the number of stupid edge cases. So we'll do node, bogus front, node, bogus back. Sup chat. Hi Advik, how you doing? Welcome back to the stream. Okay, so map is equal to new hash map. No, I mean number of present element. Oh. Is that... I feel like we can just figure that out from the map, don't we? We'll just do map.size. I don't think it's a... Yeah, it's not a biggie. We can just do map.size at any given moment, and we'll get the same. I think it's fine. New hash map. Bogus front is equal to new node. I want to make a constructor for node to make it more convenient. Public node int value, where this dot value is equal to value. I'm gonna do some bogus value at -1. Bogus back is equal to new node -1. And bogus front will for now point to bogus back. Is that a good idea? Or should we only do pointers if... Should we only point them to stuff if we actually add stuff in? Maybe null is a good idea. Okay, let's do null for now. Okay, should we do put or get first? I feel like in terms of testing, put makes more sense. we can definitely test. Well, I feel like we would need both to start testing. Okay, let's try just adding a key-value pair to the cache, yeah? Let's just try adding, yeah, okay. So how would this work? We need to put a new node in. Let's assume that this is like a brand new node, right? So like if the map does not already contain the key, then this is what you do. We have to make a new node to put at the front. Node n is equal to new node with the value. Okay. All right, great. Now the annoying part. We have to somehow insert it into. Okay, we have to put into the hash map, right? And then set it in the right order. So map dot put key n You know what? I feel like this is a good time to have a sanity check. So this is like the really bare bones feature of a cache. You put in a key and you get a key. How do we get a key? If the key exists, otherwise return -1. Okay, so basically if map contains key, the key, then you return map.get key, and else you return -1. Yeah. And obviously I am not signed in right now. Give me a moment while I sign in so I can run my code. At gmail.com. All right, we back. Let's run our stuff now. So basic insertion should work and basic read should work, but no kickouts or anything. Map.get node cannot be converted to int. What's going on? Oh, we're storing the nodes. Yeah. Dot value. Yeah. Okay. Okay. Let's see. So we put in a 1. We put in a 2, 2. We try to get a 1. Yeah. Okay. We're getting the 1 back. Very nice. We put in a 3. We try getting a 2. We should have kicked this out because, yeah, we don't handle that yet. Okay. So basic put and get is working. Now the super hard part. Okay. We need to find a way to update the value of keys and kick out evict least recently used keys. I think I'm going to try attempting eviction first. Let's try eviction first. Yeah. Okay. Freaking eviction. So if my current map size is greater than this dot size. Are you giving any contests today? Honestly, I didn't even know there's a contest today. I don't really do contests. The times are usually pretty awkward for me. Any contests today? Yeah, probably not then. I usually just leak code for like 2 hours in the morning and then call it quits. Map.size. Is that how you check size for hash maps? Java hash map size. Oh, there is. Number of key value pairs. Okay, very nice. So if my map size is greater than this dot size, you know what? This is pretty badly named. I want to return this back to capacity instead of size. Size sounds like that's how many elements I currently have. Yeah. This dot capacity is equal to capacity. Okay. Time to start evicting stuff. Okay. We know what the last element is, right? Node last node is equal to wait, I just realized something. Hold on, I'll mark this as to do. We never update the nodes. The pointers in the node, this is bad. Okay, so when we insert, we have to somehow point the nodes to each other. Update node pointers. Kuni Panda says, did you rig your model? I did. I modeled and rigged it myself, yeah. Bro, change this dot size to capacity. Oh, you're right. Thank you. Thanks for pointer. Okay, I have to somehow update the node pointers here. I have to insert this into the front, right? Insert to front of node list. Nyaharo. Oh, hi Shoharu. How you doing? Welcome to the stream. Again. Should I just do a insert to front? We might have to use this function more than once too. Say we need to, I don't know, update. Yeah, if we update the node, if we update a key value pair, we'll have to remove it and then insert it to the front too. So, oh hey Marissa. Hi Marissa, how are you doing? Welcome back to the stream. Private void, insert to front. And we'll just take a node n. Okay, so down here we will insert to front n. Okay, now the hard part. How exactly do we do this? So this should come right after the bogus front, right? Node. We should also have a pointer to the original node that comes after bogus front too, right? I'm currently doing great, thanks. Hey, nice, very nice to hear. Okay. Ooh. Oh, my mind is hurting. How do I do this? We need to track the node that originally comes after the front node, right? Let's call this the original front node is equal to bogus front dot next. Oh, but then that means we should have set up these pointers here. Advic says, when will you start system design study? Probably about like 10, 15-ish around. Yeah. Okay, we should have updated these pointers somehow. No, because now these pointers just point to null. That's not good. So bogus front dot next is equal to bogus back. Bogus back dot previous is equal to bogus front. Okay. Man, I'm so paranoid. It's so hard to test all these. Kuni says, are you studying engineering or job hunting? I'm job hunting right now. I've already graduated. Yeah. Shoharu says, how about your interview? Oh, I can share interview stories later. Okay, so we've set up our pointers in the constructor now. Now, how do we insert to the front? Okay, so the bogus fronts dot next is now equal to n. Yeah. We do this by doing it. Yeah, we do. I've been Leetcoding every day for like, I don't know, 40 something days now. I do feel like it's helping a little. I'm getting a bit faster, getting a bit more confident. Bogus front dot next is equal to n. Does bogus dot previous have anything? Probably not, right? What about n? N dot previous is equal to bogus front. N dot next is equal to original front. Yeah, okay. And if there's nothing already in the node sequence, then the original front is just the bogus back. Yeah, okay. Original front dot previous is equal to n. Yeah, that should do the trick, right? I feel like that should do the trick. I have 3 total nodes to change. That should be the one. Bogus front dot next. The previous shouldn't be an issue. N dot previous, N dot next, original front dot previous. Okay, yeah, I think this should work. So when you put a node into it, you insert it to the front, like so. Okay. I feel like that's fine. Should we do another sanity check now? Let's run this thing. Oh. This shouldn't work. Okay, so again, basic put and get should exist, but we don't cover eviction or updates right now. So that's what the answer should reflect right now. Okay, so we have capacity 2, we put 1, 1, 2, 2, 1. We try getting 1, yes, that's good. We put 1 back. We put a 3, we try getting a 2. We do return a 2. Yeah, because we don't handle eviction. Okay, I think it's working, guys. I think it's working. Shoharu says, tell us if you have been accepted for the job. Want to say goodbye and good luck. Oh, don't worry, I will. I mean, I'm not going to be gone forever. I'm thinking about still streaming while I have a job, but not as often, of course. Maybe just once a week, not every day. So don't worry, I won't be gone forever. I still want to keep up my skills somehow. Okay, now for the hard part. Freaking eviction. If map.size is greater than this .capacity, then we have to start removing some nodes. What is the node to remove? Node, last node, is equal to bogus. Bogus back. Bogus back. Dot previous. Okay, we have to be very careful here. Is there a chance that bogus previous, like last node, could give us, say, the front, the bogus front? It'll be really bad news if we remove that. So this is dependent on map.size, right? The bogus front and bogus back nodes are not counted into this size, so it should be fine. Yeah, it should be fine. Yeah, okay, I think it's fine. So what we need to do is remove. Yeah, remove it. Remove node, the last node. Let's do this in a helper function too. I feel like we would reuse this function for, say, updating. We would need to update the node, remove it, and then insert it to the front. Yeah, okay. Private void remove node. Node n. Okay. Oh. Cooney Panda says, will you become a variety streamer after you get the job? That's such a good question. I really don't know. I haven't thought about that. I do like doing coding battles that I do every week. Maybe I'll continue that. Yeah, I don't know. I have to think about it. I mean, let's not count our chickens before they hatch, you know? Who knows? I might be like job hunting for a very long time. The CS market isn't the best right now. Remove node. Node, the previous is equal to n dot previous. Node, the next one is equal to n dot next. Okay, so the goal is to point previous to next. My brain, it hurts. So previous dot next is equal to next. And then next dot previous is equal to previous. I'm starting to realize that the naming convention is horrible here. But it makes sense, right? Maybe we'll call this like previous node to make it more clear. The next node after n. Previous node. Next node. This makes sense, right? The previous node, next node. Previous node dot next is equal to next. Next node dot previous is equal to previous. Do we want to set, like, just to be safe, the pointers in node as well, and next is equal to null, and then n dot previous is equal to null. Map dot size equal greater than this dot capacity. Okay. Marissa says, same bro, same. Probably because I joined a stream with a topic I almost knew nothing about. Yeah, I remember you saying that last time. Yeah, I appreciate you trying to watch these streams, even though you know nothing what's going on. Okay, so currently our cache should handle basic, getting and putting, and then eviction, but it should not handle updates. And the test run should reflect that. Oh, equals next. Oh, next node, previous node. Okay, where are we now? Okay, instantiate it at 1, 1, 2, 2. Get a 1, yes. 3, 3. Did we somehow evict? 1, 1, 2, 2, 3, 3. Oh, it's because we haven't done the updating right. Thethian says hello. Hi, how you doing? Shohoro says one day you will understand it if you learn it, and when you understand it, you'll remember about Chet. You will remember about Chet. Okay, is eviction not working here? I feel like it's not working. We get 3 things in a row, and we were able to get it. 1, 3, 4. If map.size is greater than this dot capacity. Oh frick, hi Reified. Hello, long time no see. How's it going? It's going good. I got really nice sleep yesterday. I scored a 93 on Pokemon Sleep. That's pretty big for me. Remove last node. Oh, I know what's going on. Wait, we forgot to remove it from the map too. Map.remove the key. So now this should handle evictions. Reified says, I finally have rented new flat. Hey, congratulations. Oh yeah, you were doing that. That took a while, huh? I'm glad you got that sorted out. Okay, so we put 1, 1, 2, 2. We try to get 1. That works. 3, 3. We try to get 2. 2, 2 should be... We try to get 2. 1, 1, 2, 2. So we don't handle updates right now, so 2, 2 should be at the front. Yeah, okay, so 2 is here. We try to get 4, 4. Okay. 3. So should we not get 3, 3 and then 4, 4 here? 1. Wait, I'm doing this by 1, 1, 2, 2. So ideally 3, 3 and 4, 4 should be the last one standing, shouldn't they? If it does not contain the key, insert it to the front. You know what? Now might be a good time to print out our hash maps. Okay, let's try printing out our hash map for debugging purposes. For every single int key in what map.keyset system.out.println. Wait, do hash maps print out in a very pretty way? System.out.println current map is equal to map.toString. Let's try this. Oh, looks like it kind of does. Remove node. Last node. Oh no. Why is it only keeping 1, 1s and 2, 2s? Did you put to start if make get on the element? Insert to front. So I put the value, I put the key in, I insert to front. I feel like it should be inserting to the front. Yeah, I'm inserting to the front. You know what? Maybe we should try printing out our nodes too. Yeah. System.out.println nodes. Okay, we get the node is equal to bogus front dot next. Krishna says hello. I mean get. Oh wait, yeah. What did we do for get? Oh no, we didn't. So it's all based off of the put order. But I feel like we're still doing it wrong, right? Because I'm only handling eviction right now. So 3 and 4, 3, 3, 4, 4 should be at the front, and they're not being at the front. Okay, so while the node to print is not equal to null, system.out.print and print dot value plus space. Josh once says this is cool and soothing. Oh, thank you. No. Oh, I know. Endprint is equal to endprint.next. I forgot to update the pointer. Okay, here. Oh, the nodes are not printing out. No. The one army arrived. Why is nodes not printing out anything? That's really concerning. Am I not updating nodes correctly? Insert to front and... Okay, something going on here. Insert to front. What if I just set it to bogus front? Surely it'll print out -1, right? Oh. Wait, it is printing out stuff. -1, 1, -1. Okay, I made a mistake. And the out.println. When in doubt, as circuit breaker says, print stuff out. Okay. Yeah, this looks more right. Heck yes. Yeah. Okay. Wait, this looks right. This looks really right. Okay, actually, our nodes are like absolutely correct. The eviction is good, 4-3. You know, we aren't handling updating right now. We're just handling pure size eviction. It's the map that's doing us dirty. The map isn't being updated correctly. Okay. Why is the map like this though? So if map does not contain the key, you put the key in. Well, yeah, why isn't that happening? Why is that not happening? Let's say we want to insert 3 in, right? Oh. We're removing the current key. That's why. I figured it out. God damn. So how do we figure out what the key is of the current node? Dang it, we probably need to store it here now. Int key. No. Int key, comma int value. Oh, this is all coming back to me. List.key is equal to key. We need a way to get the key for the node too. Bogus values will be -1, comma -1. Oh, this is all coming back to me. Remove node. Put node is equal to new node, key, comma value. New node, that's good. Okay. We should have fixed everything. Okay, so when we evict stuff, we should not be evicting based on the current key that we're putting in. We should be evicting based on the last node's key. Yeah. Last node dot key. Yeah, okay. Okay. Yeah, this printout was helpful. Get is usage and cache element too. Says Rave. Oh yeah, I haven't handled that too. I'm planning to do that later. Okay, what do we have now? Okay, this is good. We're handling the 3-4 now. we're trying to get a 1, but we're not getting because that's been evicted. Yeah, okay, that's good. So now all we have to do is handle the update. As reified says, we need to handle oh wait, we need to handle 2 things. The get usage. Yeah, get usage and updating values. So let's do get usage first. I feel like this is partially clogging up this test too, right? Yeah, okay. Sure, let's handle get usage first. So getting, where are you? If contains key. Okay, so that means we need to remove the node. Okay, let's first get the node first. Node n is equal to map.getKey. Yeah, that's the node. We need to remove it and then insert it to the front. Remove node and then yeah, put it to the front. It's not a medium problem. Yeah, I agree. This is hard as heck. I've actually done this before and I still am struggling on it. Remove node. Ah, my eyes. My brain. It hurts. Insert to front. What the frick am I doing here? And insert to front. And I feel like that should work. Okay, so this should handle get usage, but we still need to handle update. We'll do that later. Let's do things incrementally, yeah? Run. Oh my goodness, it worked. Yeah. Let me just comment all this printing out. This is inefficient. Let's do n dot value. Okay. Oh. Will Microsoft actually see what your result is or not? Oh, I see what you're saying. It took me a while. No, Microsoft will not see these results. This is I'm using a website called Leetcode. It basically contains like interview questions seen in previous Microsoft interviews, but Microsoft has no visibility on this. I mean, technically, I guess they could, but they don't use these to hire people. Yeah, this is just for practice purposes. I'm just doing questions historically seen in Microsoft interviews. That's the thing. I'm not actually like trying to get hired this way. Yeah. Okay. We need to handle update. I've been saying this for so long. We need to handle update value. This worked, but that's because it didn't contain an update value. So we need an else statement here. I'm gonna leave a note here. Key already exists. So what we need to do here is we still need to get the node. Key already exists. Marissa says, thank you for answering. No problem. Node n is equal to map.get the key. Okay, and then we need to update its value. N dot what? Dot value is equal to new value. And then likewise, we need to remove the node n. We did this before, right? Remove node, insert to front. Okay. And then insert to front. Man, these helper functions are so useful. Deepak says, hi everyone. Hi Deepak. Okay. This test case should hopefully still work. Okay, nice. I want to modify my own test case. Let's say we put... let's say instead of a 4, right, we put a 1, and then we put a 100 here. So when we do a get, we should get 1, we should get 100. 3, we should get 3. Wait, should we get 3? I'm so confused. What's this over here? Put, get, so we get 2. Oh, 2 is already nothing. Okay, we should get 3. And then when we get 2 again, it will be nothing. Okay. Run. Hey, nice. Okay. Yeah, okay. 1 can be updated. 3, -1. Okay, I think we got it, guys. I think we got it. Let's freaking go. It freaking worked. Ah. Holy shizzle. Dang. Oh. That one took a lot of my brain power. Oh my freaking. Yeah, someone, Krishna says this should not be a medium problem, right? I agree. Look at how much code this is. Gonna remove all this. Oh, I'm just gonna stretch for a bit. Thanks, Marissa. Marissa says, congratulations. Dude, this question took a full hour. Yeah, it literally took an hour. That's a good stretch. Should we just do an easy question next? I want to do an easy question after this one. This one literally took an hour. I don't want to spend an hour on another question. Oh. Okay, let's pick an easy question. Freaking two-sum. Merge strings alternately. Merge sorted array. Valid parentheses. Parentheses are always hard. Longest common prefix. Should we actually just do like merge sorted array? You know what? Screw it. Let's do merge sorted array. Leetcode 88. Hopefully this one shouldn't be too bad. Oh. Okay. You are given 2 integer arrays nums1, num1, nums1, and nums2, sorted in non-decreasing order, and 2 integers m and n representing the number of elements in num1 and num2 respectively. Merge num1 and num2 into a single array, sorted in non-decreasing order. The final sorted array should not... Wait, I feel like we've done this before. It's okay, it's an easy question. Deepak says, how old are you? I'm always like, I don't know whether I should answer that question. I feel like VTubers are always pretty discreet about their ages, but I feel like I've given enough information online. You should be able to guess like how old I am anyways. I'm 25. Yeah, I'm out here job hunting. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. Okay, so it's kind of in place. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Okay. Oh. Okay. I just thought of a really dumb way we could do this. We could totally just dump. Oh, my bad. I'm not sharing the window. Oh, bam. There you go. Now you can read the question. Basically, we need to sort nums1 and nums2. Merge it together. Sort it. Deepak says, hey, we can't see the question. Yeah, sorry about that. I just turned it back onto the right screen. Marissa says, when are your normal streaming times? The time plan doesn't contain any information about it, except for the ones that are done. Oh, I don't have a set schedule, to be honest, but usually I stream every day except Sundays, and then I might take some days off, one day off here and there if I feel too tired. Yeah, basically every day except Sundays, but no promises. I don't have a schedule for now. It's every day except Sundays. How many tasks you solved total? Have you solved? Yeah, I feel like it should still be the same. 138. Yeah, 138. I feel like it should still be a similar amount to last time. I've been doing review stuff mostly. Yeah. Merge nums1 and nums2. Yeah, I just thought of a really dumb way we could do this. We could totally just copy all of nums_n to the end of m and then call arrays.sort. It's so dumb. But they're expecting us to do this the effective way, right? So they're already in non-decreasing order. Non-decreasing, so ascending order? Okay, so we should have 2 pointers on n and m. Yeah. And then, yeah, keep putting the smallest number into a new array with size m plus n, and then copy all of that into nums1. Array5 says, cool, that's not bad. Thank you. For a task like that, I know a powerful approach. Add a handle. Wait, what handle? Is it not in place? Yeah. I don't know how you would do it in place, though. You would have to shift your elements a lot, right? What I'm thinking is I would sort them all into another array with m plus n size, and then copy all of the results, copy everything back into nums1. So it's O of n time. Yeah. Just empty node in the begin. Wait, what? Empty node in the begin? You mean empty list? And let's do a temp is equal to int m plus n. Sure, let's do this. Okay, and we have 2 pointers. Int nums1 pointer is equal to 0. Int nums2 pointer is equal to 0. While nums1p is less than m, and nums2p is less than n. Krishna says, think about filling in reverse order. Oh shoot, reverse order. Is that actually gonna work? We start filling from the back, huh? How do we know we're guaranteed to not overlap though? Oh, Oh shoot. Filling from the back, huh? So nums1 plus p is equal to m minus 1. Oh shoot. N minus 1. Oh, shizzle. Okay. While nums... is greater than or equal to 0, 3 pointers. Oh, shoot. I think I'm starting to see something. Greater than or equal to 0. Yeah, the third pointer is the right pointer is equal to m plus n minus 1. I feel like that's it. Huh. This is really interesting. But how do we know that? Merce says, guys, I gotta go now. Goodbye. It was great relaxing time. Goodbye. Oh, thanks for tuning in, man. I appreciate. Wait, how do we know that we're guaranteed to not, like, overlap with what we already have, though? Oh, I'll give it a try. Oh, no worries, reified. Should we do while the right pointer is greater than or equal to 0? Okay. So if nums1 is greater than nums1 pointer is greater than, why should we put the smallest number from start when we can put the largest element from last? Yeah, I see what you're saying in the beginning, like the smallest number, if we start putting the smallest number, we overlap our existing numbers, right? But how do we know that if we put it from the back, for like from the largest, starting from the largest, that we don't overlap? We don't overwrite what we want to read to, you know? That's kind of what I'm worried about. Is greater than nums2 pointer. Okay, then nums1, the right pointer, is equal to nums1. Man, this is getting kind of difficult to read. Should I do a num1 is equal to... Is it worth doing this? I feel like it's getting so hard to read. Possibly bad naming convention too. Num2, okay. Dry run through the example of this. Okay, 2, 2, 2. Okay, so we have 3. 3, okay, so we put 3 here. We have 2. We can put either one, so 2. Let's say we did this one. So now just 3 2s. 2, 2, 2, and then 1. Oh, frick. Okay. Yeah, I see that we don't overlap with what we want to read. My mind somehow can't justify that. Like, yeah, my mind can't comprehend why we don't accidentally override stuff that we want to read though. How do we know for sure that that won't ever happen? I mean, I guess the manual test proves it, I guess. Okay. I guess that's enough comfort for me. Nums1, write p is equal to num1. And then you decrement nums1 pointer. The array are both sorted, so by the time you come to override things, things will be sorted. Then the array are both sorted, so by the time, oh, they're already sorted, so the least stuff is already packed towards the start, huh? So is it not gonna work for if it's not already sorted? Oh, maybe. Oh. Okay. I think I'm starting to see. Okay. So else, that means nums1 is less than or equal to nums2. Then nums2 will go. Nums1, the right pointer, is equal to nums2. Nums2 pointer minus. Okay. Is this literally it? Oh, also, is greater than. What happens if they're out of bounds? If nums1 pointer is less than 0. Greater than or equal to 0, then you just return that. Else you return integer dot min value. I think we should go with min value because the greater element gets written. Okay. Here is nums 2 pointer is greater than or equal to 0. Then you return this. Else you return integer dot min underscore value. Oh, and at the end you decrease right pointer too. Right pointer minus. I see. So because they're already sorted and the least elements are already packed to the start, you're guaranteed to not override what you want to read because they're already relatively in order anyways. Alright. Is this how you do it? I'm so paranoid. I haven't been sanity checking. Line 18. Oh, num2. Holy shizzle. It worked. First try, baby. Or is it? Let's wait till we submit. First try, baby. Yeah. Oh. Okay. You know what? This was actually kind of tricky too, I'm not gonna lie. I was gonna attempt it a whole different way at first, but apparently you can do it in place, so. Yeah, thanks for the tips, guys. I appreciate. Yeah, I definitely was not gonna do it this way at first. Wait, actually, I don't think I've ever done it in place like this before. Yeah. Very interesting. From back to start, huh? Okay. Good night, see you. Oh, yeah. Don't be afraid to hop off if you have to go. I'm actually not hopping off yet. I'm doing some system design study, which is like the more boring part, so. Okay. Okay, now comes the system design part. Even I was not able to come up with this trick. Really? I thought you were the one with Krishna who's advising me. Chat system. Okay, I'm gonna go take a quick 5-minute break or something and I'll come back. I'll see you guys in a bit. Alright, I'm back. I just took a quick water break. Oh, bye Reified. Have a nice day. Okay, we have been reading this for so long now. So again, this is probably the part of the stream where I'll be more silent because I'm just taking notes. Or just trying to read and understand. Okay, so I guess this is what we were looking at last time. So if user A, okay, this is what happens when user A sends a message to user B, I guess. Each user is fronted with a chat server and they communicated with some, I already forgot what it's called, some upgraded version of HTTP where they can message each other bidirectionally. No need to do like call and response format. So the chat server queues up the message in the sync queue. It gets stored in the database, the key value store. Key value store. And if they're online, we'll push it to chat server 2 that's serving user B. Otherwise, push notification servers. Okay. message synchronization across multiple devices. Okay. So each device keeps track of current max message ID. The chat server fetches the messages for them, I guess. All right. How do we know what the message ID is, though? Is it like incremental? But yeah, how do we know what the next message ID is? Oh, here, how to generate message ID. Should be sortable by time. Local ID means IDs are only unique within a group. Oh, okay. So your group, I see. So it's specific to your chat. I see. So maybe your specific chat could have a ID. I see, and then the message ID could be incremented. I see. Okay. Okay, so each user is backed with a message sync queue. Is this like a queue in our cloud service? Okay. Right, multiple users can write to the messaging queue fronting a user. Okay. Okay. So when they log out, it triggers the present servers and updates the key value store too. I mean, they could just close the window too, right? Heartbeat mechanism. Okay. So the client sends its heartbeat periodically to servers, and it has to within a certain amount of time. If it does, it's considered online. Okay. Makes sense. Wait, each friend has a queue for user A. Huh. Isn't that really expensive? For each of my friends, what if like I have 1,000 friends? Each of them has a queue for my status. Okay, wrap up. Alright, I guess we finished. I think I understand it for the most part while I'm reading it. I might spend another stream just rereading the entire thing though, because it was a lot of information. I definitely don't remember everything. Okay. Wow, we finally got to the end. Okay. I think this is a good time to stop then. Thank you to everyone who came. Thanks Deepak, Reified, Krishna. I appreciate y'all coming. See you guys probably tomorrow. Will I be here tomorrow? I think so. Alright, bye guys.